Hello, Math 141, talking about even and odd functions. If f of minus x equals f of x, then the function is even. Even functions have symmetry in relation with the y-axis. If f of minus x equals minus f of x, then the function is odd. Odd functions have symmetry in relation with the origin. Let's do a few examples. I have f of x equals x to the second. I want to know if this function is even or odd or neither. So I'm going to say f of minus x equals minus x to the second power. So f of minus x equals x to the second, because this is the same as saying minus x times minus x. So notice that I got the same function back, in this case, x squared. So therefore so x squared is even. So now at this point, some students ask, well, that is easy to remember because this would be true for f of x equals x to the fourth, f of x equals to x to the sixth, and on for any even power. And that would be true if so long as there are no translation, so long as there is no shifting to the right or to the left, then that would be true. Here is what I mean. So suppose if we say f of x equals x plus 1 quantity squared. Well, the power is even, but if I expand this, I would get f of x equals x plus 1 times x plus 1. So f of x equals x to the second plus 2x plus 1. And if I change my x's with minus x, I would get minus x to the second power plus 2 times minus x plus 1. So f of minus x equals x to the second minus 2x plus 1. And as you can see, this is not the same as my original problem. So this particular one is not even, although the power right here is an even number. Right here, this is not an even function. So we must be careful with it. My advice to you is always plug in minus x for all the x's that you have. That way you can be sure if the function is even or not. Let's do another one. How about f of x equals x to the second plus, say, x minus 2. Okay, so f of x equals minus x to the second plus minus x minus 2. And that equals x to the second minus x minus 2. Nope, not even. Now let's do a couple of examples for odd functions. The most basic example for an odd function is f of x equals x cubed. Okay, so f of minus x equals minus x to the third, which equals minus x times minus x times minus x, and that equals to minus x cubed. So notice that the requirement to be odd function, that f of minus x should be the opposite of f of x. And sure it is. Here's my f of x, and f of minus x is the opposite of my original f of x. So this one indeed is an odd function. Once again, all odd powers, so long as there is no shifting, okay, to the right or left or up and down, all odd functions like f of x, let me change my color, like f of x equals x to the fifth and f of x equals x to the seventh and on and on. They are odd so long as there is no shifting around or up and down. So how about something like as simple as f of x equals x cubed plus 1? Well, this is not an odd function anymore. There is shifting. And I can, let's show our test. F of minus x equals minus x to the power of 3 plus 1. F of minus x equals minus x cubed gives a minus x cubed plus 1. And if I if I factor a negative 1, I will get minus x cubed minus 1. Notice that this is the opposite, but inside of the parenthesis is not. So this one is not odd, not odd. Okay. Now let's bring both even and odd together and ask the question this way. Determine if f of x is even, odd, or neither. So suppose I have f of x equals x cubed plus 3x plus 1. Is this, first of all, well, let's see if it's even. So I have f of minus x equals minus x cubed plus 3 times minus x plus 1. And f of minus x gives me minus x cubed minus 3x plus 1. So certainly not even. Not even, because it's not the same as the original one. So not even. Is it odd? Let me factor out the negative. It gives the x cubed plus 3x minus 1. So not odd. And so therefore, this one is neither. This function is neither. Let's do a couple of more for the sake of discussion. How about f of x equals 1 over x to the second plus 2. Okay, so f of minus x equals 1 over minus x to the second plus 2, and that equals 1 over minus x times minus x is x to the second. I got the same f of x back. These two are the same. So this one is even. And how about f of x equals x to the second plus 4x minus 1, okay? F of minus x equals minus x to the second plus 4 times minus x minus 1. F of minus x equals x to the second minus 4x minus 1. So definitely not even, because the 4x doesn't match the negative 4x. And if I factor out a negative in front, I get minus x squared plus 4x and then +1, so not even and not odd. So this is neither. Okay, and one very last example. Suppose if you had something like f of x equals 4 minus cube root of x. Okay, so now I have to be careful with this one. F of minus x equals 4 minus, here I'm going to rewrite my function as, well, let me one more step, cube root of minus x. Okay, remember that this is the same as saying f of minus x equals 4 minus x to the power of 1/3. And this is the same as saying f of minus x equals 4 minus x to the 1/3 negative 1 to the 1/3, or cube root of -1. So f of minus x equals 4 cube root of -1 is -1. -1 times -1 is +1. And so times x to the 1/3, which is x to the 1/3, which I can rewrite this as 4 plus cube root of x. So is this function even? No, because this is not the same as this. Is it odd? No, because although this plus is opposite of minus, this 4 right here is positive, and so is this 4. So this function is neither. Okay, hope you like these examples. I'll talk to you soon. Thank you.